Welcome to our comprehensive guide on sulfuric acid, one of the most important industrial chemicals in the world. In this video, we'll explore everything you need to know about sulfuric acid for your ICSE Class 10 chemistry syllabus. From its discovery to its wide range of uses, we'll break down each concept in a clear and engaging way. Whether you're preparing for exams or just curious about chemistry, this journey will help you understand why sulfuric acid is often called the king of chemicals. Let's start by understanding what sulfuric acid is and why it's so significant in both industry and daily life. Sulfuric acid is represented by the chemical formula H₂SO₄. For this means each molecule contains 2 hydrogen atoms, 1 sulfur atom and 4 oxygen atoms. The structure is quite interesting. The sulfur atom sits at the center, bonded to 4 oxygen atoms, with 2 of those oxygens also bonded to hydrogen atoms. This arrangement gives sulfuric acid its strong acidic properties. Understanding the formula and structure is crucial, as it helps explain the compound's reactivity and its role in various chemical reactions. Sulfuric acid is a colorless, oily liquid that is highly corrosive. It has no smell when pure, but commercial samples may have a sharp odor. It is denser than water and mixes with water in all proportions, releasing a lot of heat in the process. Its boiling point is about 338 degrees C, and it has a high viscosity. These physical properties make it suitable for a variety of industrial applications, but also mean it must be handled with great care to avoid accident. Sulfuric acid is known for its strong acidic and oxidizing properties. It reacts vigorously with water, releasing heat, and can dehydrate substances by removing water molecules from them. It also acts as a powerful oxidizing agent, especially at higher concentrations. These chemical properties make it a key reactant in many industrial processes, from fertilizer production to petroleum refining. Let's explore some of these reactions in more detail in the upcoming scene. When sulfuric acid is mixed with water, a highly exothermic reaction occurs. This means a lot of heat is released, which can cause the mixture to boil and splash. That's why it's always important to add acid to water, not the other way around. This reaction is not just a safety concern, it's also a key reason why sulfuric acid is used in processes that require the removal of water, such as drying gases. Sulfuric acid is a powerful dehydrating agent. It can remove water from organic compounds such as sugar or paper, leaving behind carbon. For example, when concentrated sulfuric acid is poured onto sugar, it turns black and produces steam, as the acid removes water molecules from the sugar. This property is used in laboratories and industries to dry gases and other substances. Higher concentrations, sulfuric acid acts as a strong oxidizing agent. It can oxidize metals and nonmetals, releasing gases such as sulfur dioxide. For example, when it reacts with copper, it produces copper sulfate, water, and sulfur dioxide gas. This property is important in various chemical manufacturing processes, including the production of fertilizers and explosives. Sulfuric acid reacts differently with metals depending on its concentration. Dilute sulfuric acid reacts with metals like zinc and magnesium to produce hydrogen gas and a metal sulfate. However, concentrated sulfuric acid does not liberate hydrogen gas with most metals. Instead, it acts as an oxidizing agent, producing sulfur dioxide. These reactions are important for understanding the behavior of acids in the laboratory and industry. Concentrated sulfuric acid can also react with nonmetals like carbon and sulfur. For example, it oxidizes carbon to carbon dioxide and sulfur to sulfur dioxide. These reactions demonstrate the strong oxidizing nature of sulfuric acid and are used in various chemical syntheses and industrial processes. Sulfuric acid reacts with bases to form salts and water, a typical neutralization reaction. For example, when it reacts with sodium hydroxide, it forms sodium sulfate and water. This reaction is fundamental in chemistry and is widely used in laboratories to prepare different types of salts. When sulfuric acid reacts with carbonates or bicarbonates, it produces carbon dioxide gas, water, and a sulfate salt. For example, reacting with sodium carbonate yields sodium sulfate, water, and carbon dioxide. This reaction is often used to test for the presence of carbonates in a sample. Sulfuric acid reacts with sulfates to produce sulfur dioxide gas, water, and a sulfate salt. This reaction is important in the paper and pulp industry, where sulfur dioxide is used for bleaching and other processes. Sulfuric acid is mainly prepared by the contact process in industry. This involves the catalytic oxidation of sulfur dioxide to sulfur trioxide, which is then absorbed in water to form sulfuric acid. The process uses vanadium pentoxide as a catalyst and is highly efficient, producing large quantities of acid for industrial use. The contact process involves several key steps: burning sulfur or sulfide ores to produce sulfur dioxide, converting sulfur dioxide to sulfur trioxide using a catalyst, and finally absorbing sulfur trioxide in water to form sulfuric acid. Each step is carefully controlled to maximize yield and minimize environmental impact. In the laboratory, sulfuric acid is usually not prepared due to its hazardous nature. However, small amounts can be produced by heating iron Roman II sulfate crystals, which decompose to give sulfur dioxide, sulfur trioxide, and iron Roman III oxide. The sulfur trioxide is then dissolved in water to form sulfuric acid. This method is mainly for demonstration purposes. Sulfuric acid is a key ingredient in the manufacture of fertilizers, especially superphosphate and ammonium sulfate. These fertilizers are essential for modern agriculture, helping to increase crop yields and ensure food security. The acid reacts with phosphate rock to produce superphosphate, a widely used fertilizer. In the petroleum industry, sulfuric acid is used for refining petroleum products. It helps remove impurities and is involved in processes like alkylation, which produces high-octane fuels. The acid's strong dehydrating and oxidizing properties make it ideal for these applications, ensuring cleaner and more efficient fuel production. Sulfuric acid is widely used in the manufacture of other chemicals such as hydrochloric acid, nitric acid, and phosphoric acid. It is also used to produce dyes, detergents, and explosives. Its versatility and reactivity make it a cornerstone of the chemical industry. Sulfuric acid is used in the cleaning and processing of metals, especially in the pickling of steel. It removes rust and scale from the surface of metals before further processing. This ensures that the final products are free from impurities and have a smooth finish. One of the most familiar uses of sulfuric acid is in lead-acid batteries which power vehicles and backup power systems. The acid acts as an electrolyte, allowing the flow of electric current between the battery plates. This application is crucial for transportation and energy storage. Sulfuric acid is used in the pharmaceutical industry to manufacture a variety of drugs and intermediates. It acts as a dehydrating and sulfonating agent, helping to synthesize important medicines. Its role in this industry highlights its versatility and importance in modern healthcare. In the textile industry, sulfuric acid is used for bleaching and dyeing fabrics. It helps remove impurities and prepares fibers for further processing. The acid's strong reactivity ensures that textiles are clean, bright, and ready for use in clothing and other products. Sulfuric acid is used in the paper and pulp industry for bleaching wood pulp and removing lignin. This process produces high-quality, bright white paper. The acid's effectiveness in breaking down unwanted materials makes it essential for paper manufacturing. Sulfuric acid is found in some cleaning agents, especially those used to unclog drains and remove tough stains. Its strong acidic nature helps dissolve organic matter and mineral deposits, making it effective for heavy-duty cleaning tasks. Handling sulfuric acid requires strict safety precautions. Always wear protective gear such as gloves and goggles and work in a well-ventilated area. If the acid comes into contact with skin or eyes, rinse immediately with plenty of water and seek medical attention. Remember, always add acid to water, never the reverse, to prevent dangerous splashes. Sulfuric acid should be stored in containers made of materials resistant to corrosion, such as glass or certain plastics. Keep the containers tightly closed and away from sources of heat or moisture. Proper labeling and secure storage are essential to prevent accidents and ensure safe handling in both laboratories and industries. Sulfuric acid can have significant environmental impacts if not handled properly. Spills or leaks can contaminate water sources and harm aquatic life. Industrial emissions of sulfur dioxide, a precursor to sulfuric acid, contribute to acid rain, which damages ecosystems and structures. Strict regulations and best practices are in place to minimize these risks. Sulfuric acid is a major component of acid rain. When sulfur dioxide from factories and vehicles is released into the atmosphere, it reacts with water vapor to form sulfuric acid, which then falls as acid rain. This phenomenon causes damage to plants, aquatic life, and buildings, highlighting the importance of controlling industrial emissions. Several tests can confirm the presence of sulfuric acid in a solution. One common test is the addition of barium chloride, which produces a white precipitate of barium sulfate if sulfuric acid is present. These tests are important for quality control in laboratories and industries. Sulfuric acid is often used as a benchmark for measuring the strength of other acids. Its high acidity and reactivity make it a standard in acid-base chemistry. Understanding its properties helps students grasp the concept of acid strength and the pH scale. Sulfuric acid has a rich history, dating back to the Middle Ages when it was known as oil of vitriol. Early chemists discovered its powerful properties and began using it in alchemy and medicine. Over time, its production methods improved, making it one of the most widely produced chemicals in the world today. Today, millions of tons of sulfuric acid are produced annually worldwide. Its production is often seen as an indicator of a country's industrial strength. The demand for sulfuric acid continues to grow, driven by its essential role in agriculture, manufacturing, and energy sectors. While most people don't encounter pure sulfuric acid in daily life, its presence is felt everywhere, from the food we eat to the cars we drive. It's involved in the production of fertilizers, cleaning agents, batteries, and even medicines. Understanding its role helps us appreciate the hidden chemistry behind everyday products. Disposing of sulfuric acid requires careful neutralization, usually with a base like sodium carbonate or sodium hydroxide. This process converts the acid into harmless salts and water, preventing environmental harm. Proper disposal methods are essential in both laboratories and industries to ensure safety and compliance with regulations. In case of accidental contact with sulfuric acid, immediate action is crucial. Rinse the affected area with plenty of water for at least 15 minutes, remove contaminated clothing and seek medical help. quick response can prevent serious injury and long-term damage. Sulfuric acid is available in different concentrations from dilute to concentrated forms. The concentration affects its reactivity and uses. For example, concentrated acid is used as a dehydrating agent, while dilute acid is used in batteries and laboratory reactions. Knowing the concentration is important for safe and effective use. Sulfuric acid is commonly used in acid-base titration experiments to determine the concentration of bases. Its strong acidity and clear endpoint make it ideal for accurate measurements in analytical chemistry. Titration is a fundamental technique in laboratories and is often part of the ICSE syllabus. Researchers use sulfuric acid in a variety of experiments, from synthesizing new compounds to studying reaction mechanisms. Its predictable behavior and strong reactivity make it a valuable tool in scientific discovery and innovation. When working with sulfuric acid, common laboratory apparatus includes glass beakers, measuring cylinders, pipettes, and burettes. Using the right equipment ensures accurate measurements and safe handling, which is essential for successful experiments and reliable results. In school laboratories, sulfuric acid is used under strict supervision for experiments such as titration and reactions with metals. Teachers emphasize safety and proper technique, helping students gain hands-on experience with this important chemical while minimizing risks. In preparing for your ICSE Class 10 chemistry exam, focus on understanding the properties, reactions, and uses of sulfuric acid. Practice writing balanced chemical equations and remember key safety precautions. Reviewing past papers and sample questions can help reinforce your knowledge and boost your confidence. Students often confuse the reactions of dilute and concentrated sulfuric acid or forget to add acid to water, not the reverse. Pay close attention to the details in chemical equations and always follow safety guidelines. Avoiding these common mistakes will help you perform better in both practicals and theory exams. Let's recap what we've learned about sulfuric acid, its formula and structure, physical and chemical properties, preparation methods, uses across industries, and essential safety measures. Understanding these key points will help you excel in your ICSE exams and appreciate the importance of this versatile chemical. Sulfuric acid's impact goes far beyond the classroom. Its applications in agriculture, industry, and technology shape the world we live in. From growing food to powering vehicles and manufacturing essential goods, sulfuric acid is truly indispensable in modern society. We've explored the fascinating world of sulfuric acid, covering its properties, reactions, uses, and safety. Mastering these concepts will not only help you in your exams but also deepen your understanding of chemistry's role in everyday life. Keep exploring, stay curious, and remember, chemistry is all around us.